Okay. So I think people are gonna join in, I guess. So I'll give you a quick intro, and then we can get started. So welcome everyone, and our today's guest is I'm not gonna mispronounce your name again. Uh, yeah, so Xingyao Wang, he's the co-founder and chief AI officer at OpenHands AI. He's building open source AI agents for software developers. And before joining OpenHands AI, he was a PhD candidate in computer science at the University of Illinois. And his research interests lie in building interactive language agents powered by LLMs and VLMs. And his research has been published in top venues like ICLR, ICML, EMNLP, NAACL, and ACL. And he has received, congrats for this, NAACL 2024 Outstanding Paper Award. He received his BS in computer science and data science from the University of Michigan. And then he has also worked at Google Research, Microsoft, and Bytedance, Tencent as intern and then full-time, I guess. Welcome to Cohere for AI community. Yeah, we can get started. Thanks for accepting our invite.
Yeah, thanks, Enoch, and really, I'm really happy to be invited to be able to hear to speak here and sharing basically how our the entire OpenHands framework. So maybe I could get started. So the paper, or technically it's like an open source repository I'm presenting today, is called OpenHands. Formerly we are called OpenDevin, because the repo started when Cognition 7 released their first AI software engineer demo. And we are a open source software, which is a platform for AI software developer as a generalist agent. So the fundamental motivation for this is say you are a human developer. Say if I give you some tool like web browser, terminal, file system, and for example, a text program editor, what could you do? If you as a programmer myself, if I reflect on my everyday work, it's almost all of my work is performed using these three tools. So we think by giving the agents these a fundamental tools or fundamental action space, it's able to, in theory, it's able to perform almost all the software engineering tasks. And if you are able to, our world is written by software right now. So if you are able to solve software engineering, then possibly means you're able to solve digital agent and almost automate all of the human tasks, at least on digital world. So this was the initial motivation or the technical architecture that forms the pillar of OpenHands. But before I dive into detail there, I can share a running video for how OpenHands today works. So I just recorded this one yesterday. So we have a front-end UI. You can simply just prompt it with a natural language instruction to tell it to write a bash script that display the top story or hack news. And you'll be able to see the agent is writing files to a file system. And we also have a VS Code plugin where you can just click a button and then you'll be redirect to an open VS Code. And then if you see the traces here, you can see the agent itself will notice it's making some mistake. It's able to self-correct itself and eventually finish the task. And yeah, we also have some couple examples about browsing. So this is more an early example that we recorded. Let me see how can I, yeah. So for this is a really simple browsing example. It's basically go to our GitHub page and tell how many stars our GitHub repository currently has. And in this interface, we can see there's a view browser, and agent is browsing the website and reading the content, how many stars it has. So the goal of OpenHands is we're trying to create a platform that allows the user to use this agent for modeling and manipulation of complex systems. Basically, if you want to use AI to automate your software engineering tasks, we welcome you to use it. But on the other hand, we also wanted to build an infrastructure to enable AI to perform software development in the broadest sense. Almost all of our work on digital world involves some level of programming, and we hope OpenHands to be an infrastructure to support that. To be in a sense it's to be general enough that it's helpful to the broadest list of tasks we are performing today. And then finally, the most important thing is like we want to do it all in the open, collaborative way, in contrast to many closed source like alternatives. And that's why we call our company OpenHands AI. We want like everybody to help building, like contributing our future. So yeah, now I've started to talk about like our platform. So the main architecture of OpenHands consists of like 3 primary components. So we have an agent abstraction where a community can contribute different implementation of the agent into an agent hub. So what is an agent? So we consider an agent takes in an event history, which is like the past action and observation. And then it will output like an action. So that's all the things the agent needs to do, and that's all the things like an agent developer need to implement inside OpenHands. They just need to take care of how you convert a history into action. And then the second thing will be event stream. So event stream is more like a software architecture that allows us to track the history of action observation. So it's extremely like it's simply like a stream of messages. So the first stream, for example, here you can see the user could send the message through the user interface, and then this message will get pushed into the event stream. So this will be like a message source user. And then when agent receives that, the agent will sort of like, so the message could be like, can you create a list of numbers from 1 to 10 and create a web page to display them? The agent will start acting based on this instruction. For example, the agent could start create file, and then once the file created, the agent could start writing Python code and see the observation of Python code, like written Python code, and the agent could start trying to run the server. And then finally, the most important part, and I think it's like the most challenging part in the development of OpenHands will be like this agent runtime. So it's like a complement part to the agent component. It's like agent is like taking a history and producing action, whereas agent runtime basically converts an action and executes an action. So it produces an observation based on an action. So our implementation uses like a Docker sandbox, and I'll talk about that in detail in the coming slide. Any questions so far? Yeah, I'm happy to take any questions like during presentation if you all have any. Yeah. So yeah, then I talk about like runtime sandboxing now. So one of the biggest motivation is like for doing runtime sandboxing is like we want to do really interesting things. We want the agent to be able to run its own command and just do the things without worrying about like destroying our own computer. Otherwise, there are some cases like we observe like the agent like in order to solve a task, the agent will stumble and then try to delete like your entire like computer directory, which is like not a desirable thing to do like on your local computer. So we definitely need some sort of like sandbox here. So what OpenHands do is like OpenHands execute all the action in a Docker sandbox. What we call is like a runtime, so isolated environment. And then the OpenHands runtime support running agent on the arbitrary Docker images. So essentially what we do is like we maintain an action execution API that runs inside a Docker sandbox. And given an arbitrary Docker images, OpenHands will rebuild the image into a OpenHands compatible images by installing this action execution API. So basically, if you are a Python developer, you can just bring your own Python-based images, and OpenHands will install this action execution server inside your Python images, and you can work on you can allow the agent to work on whatever environment you want it to work on. So that was like the most challenging part, in my opinion. And so for action spaces, as we talked about earlier, we as humans have 3 primary tools. We have terminal, which have access to file system. We have a web browser, and we also have like a file editor. So here in OpenHands, we allow the agent to interact with the terminal and file system through, for example, we have like an execute action, and we also have like execute IPython shell action. So these 2 are basically similar to like how you can interact with like a terminal on your computer, or you can interact with like IPython notebook, for example, on your browser or whatever, or VS Code or something. And yeah, this browser, I'll talk about browser in the coming slide. So each of these actions have corresponding like observation from the output of like this command execution. And then for the web environment, oh yeah, sorry. Yeah, there is like a typo on the title here. So this will be like the file editor. So for code editing, what we are doing right now is like we have like 2 sets of primarily way to like replacing file. Right now we are primarily relying on the second bullet. So the way we do that is like we give the agent a tool that it's able to edit a file by replacing a specific string with another string, and that's it. Basically, the agent can just look at a file by itself and just replace some part of the string with, like, for example, the update content of a file that we can use. And finally, for web environments, we allow the agent to interact with the browser through a browser gem domain-specific language. So we basically have a browser that allows us to perform web browsing actions. For example, navigating, clicking, scrolling, and enter text. For example, here's like a screenshot of a subset of the functions the agent is able to do. For example, the agent is like able to scroll through web pages. The agent is able to select, for example, certain buttons or certain checkbox. The agent is able to fill some forms based on like their IDs. And then the web functionality is primarily implemented through BrowserGen, which is like another open source library that's specialized in browsing agents. This allows us to render HTML, PDF, as well as screenshots, and it's able to summarize HTML as a text accessibility tree. And it also allows us to do like viewport filtering, which basically means like you can filter web pages to only keep the content that you are interested in. Yeah. Before we dive into interface, any questions so far about the architecture side?
Yeah, I had a quick question. What about when it's two-way? So for example, you fetch data from a database and that's the action. And that has a dependency for a follow-on thing that says maybe like open the URL column value in the next action. How does that get played out in your event stream and runtime setup?
Yeah, definitely. That's a very interesting question. I do think our architecture can currently support that. So I think what happens is, like, for example, you're connecting to a database. There are two ways the agent can do that. Agent can just use, for example, the agent can use this file editor to create a new file. That new file you import, for example, if it's an SQLite something, I'm just assuming. If it's an SQLite, you can just from like SQL import it, create a database instance by generating Python code, and the agent will throw like Python run that script, and then the observation of that script will be pushed. So the action to run that script will push into event stream, and then that will get picked up by the agent runtime. Yeah, I should just go back to this slide. So for example, you say connect to a database, agent will write the file, execute the file, and the result of it, and then the execution request will be picked up by agent runtime, and then you end up with like command run observation like this. Yeah, this is actually the exact observation, exact type of like example you were asking for. So for example, you may see something like this. It's like you have started a development server that's running on like this port with HTML, HTTP like address. And what the agent can do is like it can simply run a browser interactive action that goes through these pages, and you'll be able to retrieve like output observation for you. So this observation it's more like a 16th version of the real observation the agent see, just for illustration purposes. Does that make sense for you?
Yeah, can I ask a follow-up? So the context that I'm coming from is like execution depending on the execution of the output of an execution before. And it's from the concept of like MPC and how they're trying to make context available for other agents from output. So is the point that you're saying is that the browser action can have some file it depends on, and that file is created by a previous action? Is that kind of illegal? Okay.
Yeah, so basically based on our like definition of the agent. So the agent has the access to the entire event history, basically entire event history, basically like everything it has done before. It's so basically when the agent is like running browser interactive command, it's able to look at like all the previous thing you have there, all the previous contact, and be able to decide by itself like what I want to do in the next. So I think what I really like about OpenHands is like we are trying to make as little assumption as possible in terms of like agent design. We hope to let the agent do all the work it wants to, instead of like us like pointing it to different directions. Yeah. Any other questions? Thanks for the question. not, I can go to the interface. As y'all just see through the UI, we have interface similar to this. This is more like an outdated screenshot. So the open source library evolved extremely fast. I think this is a screenshot from like a few weeks ago, and we just recently have like a brand new UI. And we also have like a hosted version currently available in beta. Feel free to go on to our website if you want to join waitlist, or you can just use the open source version from our GitHub. And then next, I'll talk about agents. We briefly touched upon like how we implement the agents, and here is like a more concrete example of like how we implement agents. So a minimal agent requires you to, for example, design a reset function, and then as well as writing a set function that's taking a state. So the state would just be like the action history, like all the private action observation messages. And then once you have all those messages, you just throw this message at an LLM, you will get your response. And then you can sort of decide to parse your response correspondingly. You can parse them into, for example, command run action, you can parse them into IPython run cell action, or you can parse them into, for example, browser interactive actions. And we do we interface an LLM through LightLM, which is another open source package that standardizes the LLM call across all different providers. That basically allows us to essentially support like every LLM you can have in the world. Some works well, some doesn't. And we also have like open source agent hub where people can just contribute their different type of like agent implementation if they want. And then the default agent of OpenHands is like Codex agent. So this is like the default and strongest coding agent implemented in OpenHands. So the gist of this method is like it allows the agent to basically run arbitrary action through Python or code. So it's like before this and most of the agentic tool or the agents, it's like you need to define a list of JSON, a list of tools, and then you can ask the agent or the LLM to call these tools by outputting formatted JSON. But like the problem there is like if you want to do more things, then it probably means like, for example, if I just want to look up the weather today, all I need is like weather API tool. But like in the next day, I suddenly wanted to read like the Excel file. Then I probably also need to add an Excel tool. But like as more you ask from the agent, the list of tools just get expanding so quickly. But like the idea of Codex here is like we as human, we have this like software engineer, we have the human developer, we already build like 99% of tools out there. Why reinvent the wheel? Why reinvent like all these tools by defining them ever again? So the idea here is like, hey, here's a Python. Hey, here's a Python. Here's a bash shell, and just go ahead, like import whatever package you need, install whatever package you need, because language models are trained on like the web corpus, which is like basically it's like a condensed version of like all human existing knowledge. So it knows more than you. So for example, you ask it to import the Excel file, it's able to like install pandas, which is like a library, and then you'll be able to read Excel using that library and do all the post processing. So that in that way, we are able to save a lot of like API. So it saves the human developers hassle to manually define a lot of APIs and a lot of agents to potentially do way more things than it's able to. And the third point about the OpenHands agent is like we have a micro agent architecture that allows you to customize the generalized agents like OCodex with certain level of context. For example, in our like daily development workflow, GitHub is like obviously very important because our open source project is like also on GitHub. But like the agent might not have a good way of how it should interact with GitHub because it's pre-trained on so many knowledge, so many ways to interact with GitHub. You can use like a GitHub command line API. You can use like GitHub REST API. So there's a lot of things you can do. So here, what we implemented here is like essentially you are able to simply write a markdown file, and then you can sort of like set a few triggers. And when some of the triggers were triggered by like user messages, say, hey, you go to GitHub and just pull me something, we can automatically inject relevant context into like the agent's observation, so that the agent will be able to see this like relevant guidance in terms of like how you should interact with the GitHub. And this is like user defined and quite flexible. Yeah. Any questions so far before we dive into evaluation? Yeah. If not. Yeah, that's going to evaluation. So I think this is like the part where we pour the most of our efforts in the paper. So why we need the evaluation harness, why we need to include so many benchmarks. So we recognize that if you want to develop like a general software agent, it should not excel only on like code editing tasks, but like it also needs to be able to perform like web browsing as a bunch of a bunch of auxiliary tasks. For example, answering questions about code repository or conducting online research. And some sort of use cases I run into when I was like using OpenHands is like I am thinking about implementing a new feature, but I'm not sure how to get started. And I just asked it to browse all the files, just summarize how the things works now for me, and it's like going back and forth with it. So it's not about like simply solving a GitHub issue. So that was the reason we want to incorporate as broad list of evaluation as possible. So the three main categories we evaluate agent is like based on software engineering, web browsing, and miscellaneous assistance. So for example, for software, we have like benchmarks like Sweetbench that fixes GitHub issues, as well as, for example, doing some machine learning coding and bioinformatics coding. And then for web, so web is like basically navigate a realistic web browser, like website or something to do the browsing and get information, interact with websites. And then finally for miscellaneous, this is more like a traditional LLM-based benchmark where it's like you need to answer a question based on like a monitor interaction or using a tool to browse the web to gather some information. So the highlight of like software engineering is like we primarily currently evaluate on Sweetbench. So Sweetbench is essentially a GitHub issue fixing benchmark, where the input to the agent is essentially you have like a GitHub issue that describes the issue developer is having. You have the code base and then the agent needs to take in both these two, and then they need to interact with the code base. They could edit code, they could run the code, they could run the existing unit test in order to fix the issue. And then eventually we will basically score the agent's output using unit tests. So this unit test was written like by human and to validate, for example, if this issue has been successfully fixed. So this is like very representative of like a real world task that human developer is like working on. And the second thing is like web browsing. We mainly evaluate on Web Arena. So Web Arena basically have a self-hosted, a bunch of like fully functional web application like Reddit. They have GitHub, GitLab, they have a web-stop shop, they have knowledge sources. And what the agent needs to do is like given a task, for example, here, tell me how much I spent on food purchase on March 2023. And then the agent will need to take actions and get observation from this sort of like website, and then just keep going forward until it's able to answer the questions. And then eventually the evaluation, like how we evaluate success of the agent will be based on function successfulness. For example, if I ask the agent to help me purchase something, eventually I just check the state of that website to see if that item is like really purchased or not. So this allows us to basically evaluate this with like better like accuracy. And then the most representative category of the miscellaneous assistant would be like the Gaia benchmark. So here is like example of like one Gaia question, and it's like the Excel example I used before. For example, the instruction will be like attach Excel file contains a sales of menu items for local fast food chain, and just answer some question about that. And that's also something like we ask OpenHands to do nowadays, like pretty frequently. I would just like go out on GitHub and just dump me a Excel, dump me a CSV file, so I can analyze it. And then beyond these benchmarks, in the past couple of months, we've been spending a lot of time to build up a parallel evaluation infrastructure. So the challenge here is like, because we are using a agent runtime, and then we are running the runtime inside the Docker sandbox, then it creates a challenge of like, you cannot really easily parallelize those, which makes evaluation very, very slow. For example, here, in the past, like running a Sweetbench evaluation using OpenHands was like taking like 2 days. So what we did was like, we implemented a cloud infrastructure on, for example, any cloud providers. And then you can just start, for example, a few hundred Docker images at the same time. And then you'll be able to parallel eval, and that's basically reduce the time of running eval from like 2 days to, for example, 1.5 hours. And yeah, and this functionality is currently in like closed data, and but like you can feel free to join our Slack channel if you're interested in trying out and provision like API key. And for the results, this is like a July paper. So these are the results from July. So the same Codex agent without any modification to its system prompt. It demonstrates like competitive performance across 3 major task categories, which are like software engineer, web browsing, and reseller system. And then yeah, that's basically the takeaway. It's not the best at everything. It was not the best at everything, but it's able to work on everything without significant modification, which is like one of like our primary motivation. We want to build a real general agent based on software that can work on any software, that can work on a lot of different tasks. And then the most recent result we got is like it's October. I mean, like a few months after paper publishing. Recently, we get into like the best score on Sweetbench, verified and light. For example, right now, OpenHands score about 53%, which is like I think it's like the first system, AI system that surpassed like 50% mark on Sweetbench verified, and it's open source, and it's like open source in MIT license, so that's a good thing. And then we also have like some results about like different models, like open source models versus like proprietary model. So the state for now is like this is from October, so before we get this state of the art. So but like the takeaway here is like proprietary model currently still works the best. Like we have a couple research collaboration going on our community that aiming to bridge the gap here and making open source more useful for everyone. Yeah. And and OpenHands is like not a static system. It's not a static software engineer library where it just goes on stale and everything. That's it. We are continuously adding more and more exciting agent benchmarks into OpenHands evaluation kernels. Just in the last couple of weeks, we have like Science Agent Bench, which evaluates language agents on data-driven scientific discovery. We have MLE Bench from OpenAI, which allows the agent to work on Kaggle competitions and solve them. And we also have a commit zero benchmark. Just the PR just emerged like 2 days ago or something. It's basically a from scratch code generation challenge that it's like you have all the test cases and the agent just needs to implement all the functionality to pass all the test cases. Yeah, any questions so far? Yeah, finally, I guess this is like one of the last slide I have. We are really appreciative of our OpenHands community. So OpenHands started really with a tweet and really shortly after Devin comes out. And right now we are an open source community consists of like more than 200 developers who joined us in the last 6 months or so. And we now have like 37K stars, and we are one of the GitHub top 100 Python projects. And we have a lot of researchers from many institutes, for example, CMU, UIUC, Berkeley, and others. Also have like member of several companies who are like excited about like agents, excited about software writing agents, and excited to use it and help it improve us like going forward. Yeah, any questions so far? Before I go into development roadmap. Yeah, so I guess there are several things we've been working on, for example, on the agent quality side, on the agent ability side, as well as on interface side. So we have basically the quality side, the remaining problem would be something like how to better localize files in very large repositories, say with like tens of thousands of files. What's the ability to interact with the user when user provides like uncertain questions? So the agent could, for example, if you just provide a really vague instruction, the agent could just do whatever it thinks is right without ever consulting you. And then can we bridge the gap between open source and closed source model by training models on agent trajectories? In terms of like agent capability, how do we perform the browsing better? And how do we support multimodal better? So right now, you can just simply paste like your screenshots into OpenHands, and OpenHands will read those screenshots. But like it would be also nice to be able to just pinpoint OpenHands to a local code repository where it has like a README that contains a link to an image and is able to read those images. So how do we basically allow it to do that? And in terms of interface, how can we sort of like further improve our UI to make it like more intuitive for users to use and make it more useful for our product? yeah, and I guess this is like the conclusion page, and just as we talked before, OpenHands is like for 3 different types of like user profile. For example, for agent user, we want to provide an easy use interface to finish coding and web tasks. For agent researchers, we hope OpenHands provide OpenHands provide the infrastructure that allows you to do sandboxing, evaluation, and have a bunch baseline to allows you to do research quickly. And if you contribute your agent to OpenHands, more and more users and researchers may use it. And finally, for open source developer, OpenHands is like an interesting project to help deliver advanced AI capabilities to more users. And we are open project, so we encourage people to join our GitHub, join our Slack, or join our Discord if you're interested in discussing or seek for collaboration on any of the research ideas. Yeah, I guess that's all for my presentation today. Happy to take any questions.
Yeah, thanks for this great presentation. Yeah, I'll open the floor for a few Q&A. Yeah, so if anyone got hands, you can feel free to unmute yourself and ask the questions, or you can drop them in the chat if you want, and then we can read them aloud. Maybe until then, I can start with my question. So I know you guys are using external LLMs for the main part, right? But in the sandbox, is there any like implementation to prevent, like, for example, unauthorized access or like some malicious activities that maybe the model doesn't support, or that the model is doing, or something like that? Does it have any measure like to prevent such unauthorized access in the sandbox?
Yeah, so yeah, that's a very good question. So I think currently what happens is that we basically allows the agent to run on different modes. So we can ask the agent to run as root, where it have like almost every access inside the sandbox, but like not outside the sandbox. Or you can just give the agent like as an ordinary user, where it can just modify a file, install some like Python packages, but not system level packages. Like for now, we primarily allows the agent to basically do everything. It's like your root, you can do everything inside the sandbox. But like because of the runtime, because of the sandbox mechanism, so the folder provided by user is some. For example, if you have a GitHub repository, the repository is like cloned inside the sandbox. So even if the agent messes up, it doesn't really like bother you in a sense. And then for the security guardrail, we have like a security analyzer. This is like in collaboration with University AI, which is another startup that focus on like agent safety. So we basically have a security analyzer where we have a action confirmation mode. So if you have that mode turns on, the security analyzer will analyze like every action the agent emits, and then it will sort of like evaluate the security risk of the action. For example, this action is like RNRF, like entire root directory. Then this is like obviously a no, and then you basically prompt the user say, do you want to wipe out your computer or not? And then if the agent just executes some like harmless bash command like a list folder, then the security analyzer will simply just let it go to execute those actions. Not sure if that answers your question.
Yeah, that's a good answer. Thanks. Yeah. So any questions?
Yeah, sure. Let me get back in terms of like for people starting out, OpenHands is probably a good one to check out. But is there? I think I've heard of like Meta GPT or something like that. I'm not sure. Just like agent orchestration libraries. What are some of the simpler, most popular ones?
Yeah, I think Meta GPT and maybe AutoGen, some of that is also a popular. It's also like a popular software libraries for agents. But like I think most of the existing libraries are primarily focused on like a multi-agent, and I think personally I think the most challenging part is like agent runtime, and existing library have relatively limited support for agent runtime. But it really depends on the task you are working on. You wanted to work on, I'd say, but there's like a lot of great library out there, and we actually included in the paper. There's like a related work comparison table where we compare OpenHands against like different different existing libraries.
Gotcha. If you were to try and build sort of a browser use like example, where like somebody chats with like a set of tasks, and I don't know if you want to use Puppeteer or something, but how would you go about building it in within the OpenHands framework? So I would assume you'd want to set a web use agent, and then maybe like some of the user interfaces are just like piping in the chat and asking an LLM to kind of generate a bigger instruction for the agent. Is that the general shape of how you tackle sort of like find all the prices on Amazon.com, for example, for store products?
Yeah, I think that could be the way to go, actually. So actually, I think there is like probably two ways. If you simply ask it to find like all the prices on like all Amazon, the agent could start like, if you're asking a general agent, the agent could start writing like a software program that start crawling those websites. So that could be like one way to do it. If it's able to get it done, it's probably more efficient than having LLM to using a browser. But like if the agent got banned or somewhat, on the other hand, if you just want like a LLM-driven web browsing agent, and in OpenHands, what we can do is like essentially you can just remove the, for example, you can remove the Python server, you can remove the bash shell from the action space, and then you only ask the agent to interact with this browser. And then it's like you can just say something like, go to URL, some URL, find me a list of like prices on these web pages, something like that. And then agent would sort of like complete that task. But I still think maybe the first, if we are parsing like a structured website, the first route could be potentially useful as well.
That's a good point, actually. If other people have questions, feel free to join in. I'm just excited to have him here and don't want to use up too much airtime. Okay, there's a question.
Yeah, that's a great question. So it's like what's happening inside the model and understand how the agent makes decisions. But like I think the major challenge here is that this sort of like frontier capability right now only exists in frontier models like provided by like OpenAI or Anthropic. And those models are closed source, which means like we have a little way to basically run mechanistic interpretability methods like that. But like we are really working on to get the open source model working on that. And maybe after that, we were able to do more sort of like this deep analysis into like how the model actually performs when the agent runs the task. That's a good question. But like because we are open source, we actually have the entire event stream, basically all the event action observation stream passing to the agent available. And then we also upload them to a Hugging-Face space where we host our evaluation results, and as well as like the sweep benchmark where we submit all our submissions. So I think currently we are mainly analyzing like the action and observation themselves instead of like analyzing something that happens deep inside the model parameters. Not sure if you answer your question. Feel free to speak up if you have any follow-up.
Yeah, so until then, I also have one question. So I saw one of the limitations would be integrating some like VLMs, which will have some missing information from like visual context and stuff like that. And then also with longer context, like for example, complex, huge code base, right? So is there maybe like, I don't know if you have implemented it here or any plus in the future, but is there any way of doing maybe chunking like this complex code to fit in the context length, or like use external like VLM sources to like interact visual inputs? Like, is there any things like that?
Yeah, so I guess for the first question, visual inputs, we do support it right now. So you can just simply, it's like similar to how you can interact with a ChatGPT. You can simply take a screenshot, paste it into the chat box, and then you can just type whatever you want. And then the agent or the underlying LLM, if they support visual inputs, they will be able to see your screenshot and continue working on that. But like that's how it's like this capability is like primarily exists on frontier model like Claude on it, or like GPT-4 or something. Like for open source models, we currently don't have good support for that. So that's definitely something we want to work on. So eventually, we want a like a really open source model that's able to do, for example, 60 to 80% of the things frontier model is able to do in terms of featuring in OpenHands. And then I think the second question was context window, and that's actually a very, very good question. So that's something we've been actively working on. And what the one of the simpler solution we've been implemented is like if your message got too long and you sort of like just truncate the first view and bring it back to, for example, if you can set a threshold, say like 128K tokens, so you can just say if it ever exceeds the context window, you can sort of delete the first few messages and truncate it back to 128K tokens. Like we are also experimenting smarter smarter approach. For example, we can just like selectively summarize some of the observations. For example, if you install a Python package and the pip install gives you like 1,000 lines of output, just to tell you you have successfully installed the messages. So I guess in the follow-up turn, what you can really easily do is like you can just summarize that 1,000 lines into like one line. You successfully installed this package, and that's it. So that's also another thing we're being actively working on. But like in general, I think the agent memories, this sort of like short-term memory as well as how it can interact with like potentially long-term memory, still an actively research field where a lot of people are working on this exciting problem.
Got it. Any other more questions from the panel?
So back to my browser use kind of question. So I found the ideal use case, and I'm trying to get a better understanding of it, is just log in everywhere and update my home address, for example. The first, if I was to think through an event stream, it would be like get list of accounts or websites and like a password. Maybe that's stored in a CSV or something, and then open URL and then find settings. Would that like the find settings instructions, the settings page, or like authenticate if it's not authenticated? How would those kind of how do you dispatch like two different kind of instruction sets? Would that be like the agent opens a page and then like responds back like need to authenticate?
Yeah, I think that would be the ideal workflow. You could just tell it like, here's a list of URL. Just go out there and update my home address to XYZ. And what happened was like the agent goes to the website, try to find the setting, click the setting, and then observe the setting and see, okay, you are not logging in. Agent should, the ideal pattern should be like the agent will get back to you, say, hey, you're not authenticated, can I have your password or something?
Interesting. Is there a way to instrument the like authenticate flow? For example, as an agent action that I like fine tune or train or something like that?
Sorry, you mean the authenticate? What do you mean by authenticate flow? You mean like how the agent performs? Are you asking, can we train a specialized model just for the authentication process?
More like I suspect between CAPTCHAs, needing to ask for a password and stuff like that. Is there a way to, I guess, deploy a browser act agent that I have fine-tuned by showing it how to log in on like 50 websites, and then that's the action it can kind of invoke, which is browser use, but a specific one that's been like
I think that's definitely possible and doable. I even suspect that if you're just prompting off-the-shelf model like Claude, it's already able to do this type of like logging. But like I think the trick here is like you sort of like wanted to separate the browsing section. So basically you divide this task. For example, if you want to visit like 50 websites and change your home address on that 50 websites, you could like dispatch 50 instances of browsing agents. And then for each browsing agent, all you need to do is just update address on one app website. So that makes the problem slightly easier for the agent. And I think that will just work.
Okay. If you were to compare this to the computer use version, which is basically it like screenshots and asks Claude after it gets to a certain stage, Claude gives instructions. What would be the key difference here? Is this the like multi-turn user agent interaction as like the missing piece?
Yeah, I think on a high level, basically, if you are not considering any technical detail, we are actually pursuing the same thing. It's like user, you just need to say anything and I'll do everything you need for you. And that's the goal. And by the way, we are also adding supporting for like a computer use into this browser, into this browsing. So, and then from a technical perspective, I think the main difference is like we are currently using like text-only accessibility tree, which is basically like a simplified version of HTML, where the agent reads into, like, for example, the source code of the website. Whereas computer use for Anthropic, they directly read the screenshot. Like going forward, we do feel like reading the screenshot itself can be a more general approach because the web is like really messy, and parsing HTML, you get a lot of like weird things.
Yeah.
That is not entirely agent's fault, but it's weird for agents. So yeah, we are also moving to that direction as well. But yeah, stay tuned. Hopefully we can just incorporate that in the coming weeks.
Yeah, you almost need a browser like a neural engine that just like represents the neural effects of the code, but doesn't really spit out pixels, so you can just like easily scope into the action. But yeah, this is exciting stuff, man. Thank you for answering my question.
Yeah, thank you for your questions.
We got one question in the chat.
Oh yeah, let me just say. Will it be highly expensive to follow routes of the video? Yeah, so I think one of the limitations right now is like OpenHands currently only support these frontier models because this is really like the frontier capabilities in terms of like, but like as we see in the past few years, the cost of the LM just goes down like drastically. Right now, it's like 100 times or even more cheaper than what it is before. So we are actually pretty optimistic on that in terms of like optimizing costs. If you are relying on frontier like model developers, for cost optimizing. But like on the other hand, we do have an open source project, research collaboration that works on fine-tuning an open source model that's able to perform tasks on OpenHands. And we are making good progress there. And hopefully we'll be able to share something maybe by the end of this year so that everyone can just use their laptop to host a smaller model. That's probably not as good as frontier model, but like they were able to perform some sort of like task. And then the second thing is like require a lot of clusters. I think the remote, I'm not sure if you're referring to remote runtime or something, but the remote runtime is only required when we are developing the agent and running large scale evaluation to make sure the new, for example, the changes we introduce in the agent allows the system to perform better. But like if you're just using locally, you can simply go to our page and clone the Docker images, and it's able to like run on your own laptop without like requiring like a huge cloud infrastructure to set up. And you can also sort of like sign up for our waitlist, and it's as simple as like going to a URL and just start interacting with the agents. Yeah. Not sure if I answered your question. Yeah. But thanks for the question. Do you think computer use can be, beyond your question, do you think computer use can be an agent that can be blended in when you have screenshot capability in the industry? Yeah, so right now, actually, the editing function is also part of the computer use capability from Anthropic Cloud. And this is like the computer use is more, so the Anthropic computer use is more involved in terms of the agent's implementation. Basically, when I take in action observation, I choose to implement my agent using the computer use functionality from Anthropic. Something like that. Not sure if it makes sense to you.
Gotcha.
Okay, awesome. So maybe as the last point of questions, I want to ask you a few things. So how was the OpenDevin project started? Because I remember Graham Newbeck from CMU sharing about it and everything. And then it quickly got off to a point where it was like this big competitor to Devin, which nobody expected. And then some people also dropping out from their PhDs to pursue this full time, right? So how was the process of moving to that? Just if you can tell us about it, and then how was making it to a startup level as maybe a conclusion point?
Yeah, that's an exciting journey, exciting ride. And by the way, I'm the one who dropped out of PhD to join the OpenHands full time. But anyway, so I think it all started with like Twitter and README after Devin comes out. Like people are like really excited about the capabilities of building an AI software engineer, and because Devin really showed the demo, so people think it's not impossible to build it now. And the entire open source community was like super excited about that. So once that Twitter and README comes out, I think it's like instantly the repo with only one README file got like 1,000 stars, 1,000 GitHub stars, and everybody was like super excited about that. And I think Graham was like the initial people who said, okay, we should put a really bad looking, not working front end interface, just mimicking Devin, and then just put it out there. And then the amazing thing just happened, like the entire open source community. So we have like it's like there's no central coordinator of some sort. It's like everybody just start working on their own. So say like, I want this one to be added. So people just start PR, contributing code. It's like the first month or so, it's like very chaotic. You have PRs floating everywhere on GitHub. It's like, and even some people will just, even two people will like submit the two PRs that try to implement the exact same feature, something like that. That was like the first chaotic month. And then I think Robert, who is like currently our CEO, he joined in, and he was like mainly focused on making the architecture of OpenHands. It was called OpenDevin at that time, useful, and then build like the first agent. So the system can right now run end to end. For example, the front end can send requests to backend, and backend can connect to LLM and dispatch an agent and have it work on some really toy tasks. And then I sort of jumped in. I brings my past work like Kodak, and I was saying, okay, can I just create an agent with my past experience and integrate it into OpenHands? And then because like the one of big motivation, one thing I realized when I was doing research at the university is that to do agent research, to do real useful, impactful agent research, you need to write a lot of code. Otherwise, like you are just playing with toy problems. For example, real world software engineering problems. For example, you typically spend like, I don't know about your guys. I typically spend like, for example, 80% of my first day like setting up the code like software project. It's like taking a lot of time to set up. And a similar thing applies to agents. In order to allow the agent to solve this type of complex problem, you need to do a lot of the complex code around it. And then I was already in the halfway of like writing code for my next research project. I was like, okay, OpenDevin comes out. Maybe I can just port all my this existing code I've been written, just port them into OpenHands, make it a exciting open source project that people are excited to use. And then this way, it's like I got a robust software infrastructure I can use for my own research. But like people also got a very useful product that can improve their productivity, something like that. And I was like super excited about that. And at this point, it's like we already sort of like make some of those milestones there. It's like we have a pretty useful code base for research different agent ideas and doing all the research while even ourselves is like using it pretty extensively on a daily basis. And I think on November, like 20% of the code in OpenHands code base is now written or it's like authored or co-authored by OpenHands, which is like a great signal of like it's actually very useful in our everyday developing process. Yeah, and I think at some point we decided to start a company because like I'm really passionate about this open source project and I don't want to see it die. Because like if I have other obligations, I want to work on research, I probably won't have like that much time to contribute to this project, and so did others. I mean, to keep like a project alive, sort of like need a few people that's sort of like full time really dive into it and maintain the code base. So it keeps running and keeps adding newest features when like new things come out. So that was like one of the reasons we decided to found a company. We want to keep this project rolling forward, bring more value to people, whereas bring more value to researchers like myself and bring more value to open source users where people are like, I mean, agentic technology is like, in our opinion, it's like too important to be like built behind closed doors and only owned by like a few big corporations. We hope everybody to have a sense of like what's going on under the hood and be able to contribute to it.
Awesome. Let's give it up for Xingyao, and thanks a lot for accepting our invite. And then I'll be uploading this on YouTube maybe tonight or tomorrow. So we'll have the recording. Thanks a lot for accepting our invitation to present here. And then for all who attended, thanks a lot. And then keep up with the Discord Cohere for AI channel for more classes like this. Yeah, thanks everybody.
Yeah, thanks for the invite. Thanks everyone for the questions. Great questions. Great.
All right, thanks.